Okay, on problem number 1, the directions say wants us to evaluate this integral. We've got the integral of the square root of x cubed dx. The very first thing that you're going to want to do is you want to change your square root sign to a half power. So changing the square root sign, we're going to rewrite this as x to the 3 halves. Now that we've rewritten it as x to the 3 halves, we can go ahead and just integrate it directly. So remember your rules for integration. You just add 1 to the power, and then that's just all divided by that power plus 1. So notice I'm going to take my 3 halves, I add 1 to it. So I got x to 3 halves plus 1. That's going to be all over 3 halves plus 1. Well, 3 halves plus 1 is going to be to the 5 halves. And that's going to be all over 5 halves. And then you just go ahead and flip and multiply. So here's x to 5 halves, all over 5 halves. You flip that denominator there and you get 2/5 x to 5 halves plus c, which is what your answer is for number 1. On number 2, directions are the same. It just wants us to go ahead and evaluate this integral. So if you remember correctly, this is just a direct integration. We know that the derivative of the cosecant is the cosecant of x, cotangent of x. So going backwards with it, it's just a direct integral. So you're just going to go ahead and replace this cosecant of x, cotangent of x with the cosecant of x. And remember the rule is that when you're done integrating, if it starts with a c and it's trig and you're done, that's going to make it a negative. So your answer, just direct integration from your memorization, would just be -3 cosecant of x plus c. Okay, on number 3, they want us to go ahead and again evaluate this integral. And we've got the integral of x cubed minus x squared all over x squared. Remember, if you have a monomial in your denominator, always separate out your numerator with those separate monomial denominators. That way you can go ahead and just solve it directly. So first step is just algebra. I'm going to rewrite my integral so that it is x cubed all over x squared minus x squared all over x squared dx. Now that I've done that, I can use my algebra to go ahead and simplify this down. So I know that x cubed divided by x squared is going to give me this x for my answer. And x squared divided by x squared is going to be 1. Now that I've simplified this doing my algebra, I can go ahead and integrate this using my laws of integration, your basic power rule, which just says you just take your power. And you'll notice that even though it's not written, this does have a power of 1. So over here I've continued it, so I got x the first, so this is going to be 1 plus 1, and that's all over 1 plus 1. And so that would end up being x squared all over 2. And then again, by the 1, I have my x to the 0, so you're following your basic rule. So you take 0 plus 1, all over 0 plus 1, and that's going to give you that negative x, and then plus c. So your answer to this problem on number 3 would be x squared all over 2 minus x plus c. On number 4, it says we have the integral. It says evaluate the integral of cosine cubed of theta all over 2 minus 2 sine squared of theta. So the very first thing that you want to do is you want to take your denominator, and we're going to factor 2 out of it. So factoring out of 2, we're going to get 2 times 1 minus the sine squared of theta. Now the reason why I do that is because I know that 1 minus sine squared of theta is a Pythagorean identity that I can change to the cosine squared of theta. So that's what I'm going to do next. I'm going to go ahead and change this 1 minus sine squared of theta, and that's a Pythagorean identity. So this 1 minus sine squared of theta now becomes a cosine squared of theta. So now I can simplify this down using my algebra. I've got the cosine cubed of theta all over 2 cosine squared of theta. So cosine cubed of theta divided by cosine squared of theta simplifies down to cosine of theta all over 2. Now I'm going to go ahead and bring my 2, put it out front here, so that's going to give me that 1/2. And then I can just go ahead and integrate it directly. So I know that the integral of the cosine of theta is going to be the sine of theta. And I still have my 1/2. So my answer is going to be 1/2 sine of theta plus c. On number 5, says find the function y equals f of x if f prime of x equals 2x minus 1 and f of 1 equals 3. So notice I've got f prime of x equals 2x minus 1. That's my first derivative. So I'm going to go backwards with it to find my original equation. So this is going to be the same thing as the integral of 2x minus 1. So following my rules of integration, remember this is a 1, so I'm going to take 1 plus 1 all over 1 plus 1. And when I do that, I end up with this being x squared. Now integrating this next one, I got a negative 1 here. If you want to think of that as being x to the 0, you got that 0 plus 1 all over 0 plus 1. Or in other words, its integral is just going to be that negative x. And then at the very end, I've got my plus c. So here's my original equation that it came from. I've got y all equals x squared minus x plus c. But since I'm given this value, this function value that's given to me in my problem, it says that f of 1 equals 3. I know that this right here is my x value, and this is my y value. I can go ahead and substitute that in to find the value of c. So I'm substituting in 1 in place of my x's. And I'm going to place that 3 in place of my y. And then I can go ahead and solve that to find my value of c. So solving this equation, I know the 1 squared is going to be 1. 1 minus 1 is going to be 0. So that's 0 plus c all equals 3. So now I get c equals 3. So the equation that came from was y all equals x squared minus x plus 3. On number 6, the problem says use a of t equals negative 32 feet per second squared as acceleration due to gravity. An object is thrown vertically downward from the top of a 480-foot building with an initial velocity of 64 feet per second. With what velocity does the object hit the ground? So you're going to notice that the a of t equals negative 32 feet per second squared. That's acceleration. Any object that's thrown in the air or any object that is dropped, immediately gravity starts to pull on it. So that's effective gravity. It's going to negative 32 feet per second. And that is your acceleration equation. Now when I go backwards with it and I integrate, that means that I'm going to end up with my velocity equation. So integrating my acceleration equation gives me my velocity equation. And then the integral of negative 32 is going to be negative 32t. I'm going to have that plus c. Well, since my original velocity given to me in my problem was 64 feet per second, when I substitute that in, I'm going to find out what my c value is. And on your homework assignment, you basically figured it out, because when you substitute in that negative 64 and you substitute in that 0, you're going to end up with your c value. That's always going to be 0 right here. And so your c value is negative 64. So that means that my velocity equation is negative 32t minus 64. Okay, now I'm going to go backwards with it again. So going backwards to find my position equation. So the integral of v of t is your position, which is s of t. I'm going to go ahead and integrate negative 32t. So remember that's the 1 plus 1 all over 1 plus 1. So when I do that, I get negative 32t squared all over 2, which gives me that negative 16t squared. And then when I go ahead and integrate the negative 64, well, remember that is t to the 0. And you do the 0 plus 1 all over 0 plus 1, which is going to give you that negative 64t. So far my position equation is negative 16t squared minus 64t plus c. So now, if you remember correctly, it told me my initial position. So up top here, we'll scroll up to it again. My original position was at 480 feet, because that's the building that I was standing on top of. So that means that S of 0 equals 480. You can substitute that in to find your value of C. So substituting that in, you'll notice I went ahead and put in my T is equal to 0. My S of T would be 480. So notice that still comes out to be 0. That's going to cross out, and you're left with your original position of 480. So there'd be my position function. My position function is going to be S of T all equals negative 16t squared minus 64t plus 480. So now I have all three of my equations. So I've got my acceleration equation, I've got my velocity equation, and I've got my position equation. So I've got A of t equals negative 32. That's feet per second squared. That's your acceleration. Your velocity would be negative 32t minus 64. And your position function is going to be negative 16t squared minus 64t plus 480. So now the question is, it says with what velocity does the object hit the ground? So what I'm going to do is I'm going to factor the position equation to find the time when the object hits the ground. So that's going to be my next step. So I'm going to go ahead and factor that velocity, or sorry, that position function. So when I factor it, you're going to notice that it isn't factorable. So I take out that negative 16, I get t squared plus 4t minus 30. It's not factorable. So now I have to take this, and since it isn't factorable, I have to use my quadratic formula. So remember, from this equation right here, here's your A value, which is equal to 1. Here's your B value, which is 4. And here's your C value, which is negative 30. Putting that into the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So the 4 is going to go in place of my b. So I got negative 4 plus or minus the square root of 4 squared minus 4 times, here's my a value, 1 times c. And then that's all over 2 times 1. So now working that out, I just go ahead and put the 4 squared minus 4 times 1 minus 30. And I take the square root of that. So 4 times 1 times negative 30. Put that into my calculator, and that gives me 11.66. So now I'm going to take negative 4 plus 11.66 divided by 2. And that gives me the 3.83. I got negative 4 minus 11.66 divided by 2 is a negative 7.83. So with those two values there, I know that it hit the ground after 3.83 seconds. So now that I know that, I just go back to my equation. I'm going to substitute in that 3.83 into the velocity equation. So here's my velocity equation. I got negative 32 times 3.83 minus 64. Put that into your calculator, and you'll get that velocity of negative 186.6 feet per second. On number 7, the directions say on number 7, let S of n equal the summation of I equals 1 to n of 1 plus 2i all over n times 2 over n. It says find the limit of S of n as n approaches infinity. So substituting that in, here's my equation. So my equation that I'm finding is the limit as n approaches infinity of the summation of I equals 1 to n of 1 plus 2i all over n times 2 over n. So now notice this is our constant, so I'm going to go ahead and put that out front. That still is the limit as n approaches infinity. I'm going to go ahead and break apart my summation right here. So I can break apart my summation across the plus sign. So I'm going to take this part of it, and this becomes the summation of I equals 1 to n of 1. And then here's my second part. So this becomes the summation of I equals 1 to n of 2i all over n. Now bringing out more constants on this next part. So again, here's my constant of this. So putting that out front, that is 2 over n. So now I'm just left with the limit as n approaches infinity of 2 over n times the summation of I equals 1 to n of 1 plus 2 over n times the summation of I equals 1 to n of I. And so you'll need to remember your I formulas on page 260 for this test. You'll need to memorize them, so make sure you have them down, because you're going to need it to find this answer for this I. So notice our 2 over n is a constant, stays the same. This is n times 1, which just becomes n. And then I still have my 2 over n. And then my formula for I is n times n plus 1 all over 2. Now we're going to go ahead and take the limit as n approaches infinity. And remember when you do this, we talked about how the binomial theorem and the binomial expansion, all the powers just drop down by 1. So I don't really need to do the entire equation. I can just do that first part of the equation. So I'm going to distribute this on through. So this becomes 2n all over n. I'm going to distribute this on through also. So this is 2 times n times n. So that times this times this. It's going to give us that 4n squared. And then I'm going to take this n times by 2. That's going to give me the 2n squared. So all I have to do is just do the first term of each one, because preceding that, they're all just going to drop down by a power of 1. So now to find the horizontal asymptote. So the horizontal asymptote of this, since the power is the same, that answer is just going to be 2. Power is the same, so that's going to be 4 divided by 2, which is also 2. And then 2 plus 2 is going to equal 4. And that will be the limit as n approaches infinity at that summation of I equals 1 to n of 1 plus 2i over n times 2 over n. Okay, on number 8, the directions say on number 8, it says write the definite integral that represents the area of the region enclosed by y equals 4x minus x squared and the x-axis. So we're going to go ahead and graph it first. So to graph it, we're just going to go ahead and factor it. So notice, I go ahead and factor this, and when I factor it, I get y equals x times 4 minus x. So I just took out a common x, and rewrote that as x times x minus 4 minus x. So that means that my x-intercept is at 0 and at 4. So since it's a 0 and 4, I go ahead and put this at 0. I put it at 4. So here is my equation, negative x squared, which means that's a parabola that's going to be opening downward. So notice it's confined by the x-axis. So to write this area, I went ahead and shaded in the part of what that area represents. So I'm going to go from, here's my x value, 0 to 4. So here's 0, here's 4, and that's of the equation 4x minus x squared dx. And so that would be your integral that would represent that shaded region. On number 9, it says I got the d dx of the integral from 2 to x of 2t squared plus 5 out of the second power dt. So according to the second fundamental theorem of calculus, an integral and its derivatives are opposites of each other, so they'll cross out. And so all I have to do is just substitute that into my equation. So my variable goes into my equation. My answer is going to be 2x squared plus 5 all to the second power. So remember, from the second fundamental theorem of calculus, your derivatives and your integrals are opposites of each other. Okay, on number 10, it says use the fundamental theorem of calculus to evaluate the integral from negative 1 to 1 of the cube root of t minus 2 dt. Well, it didn't really say that I had to. It says to use the fundamental theorem of calculus. It didn't really say that I needed to say that, because basically it just means you can find an integral. So that's what I'm going to do here. So I'm going to rewrite this. So remember, the cube root becomes a third power, and I still have my minus 2. So now to solve this, remember we're going to take the 1/3 plus 1 all over 1/3 plus 1. So 1/3 plus 1 is going to be 4/3. And that's going to be all over 4/3, which flips and becomes 3/4. So I got 3/4 t minus 2t. Let me scroll that up a little bit so you can see it a little bit better. And now the integral of this next one, minus 2, is just going to go ahead and become minus 2t. Because remember, that's t to the 0. And 0 plus 1, all of that, 0 plus 1 will just give you that t. So this right here is my integral. So now I'm going to evaluate it from -1 to 1. So that means that I need to find f of 1, and I need to find f of -1. So substituting in those numbers into my equation. So here's f of 1. So I got, when I put 1 into here, I get 1 to the 4/3. So the cube root of 1 is 1. 1 to the 4th is 1. 1 times 3/4 gives me this right here, which is 3/4. And then I'm going to go ahead and substitute in 1 over to here. So that's going to be the minus 2. I'm going to subtract my f of -1. So putting in -1 with this equation right here. So that still comes out to be 3/4. Now putting in the -1 with this equation right here, that's going to give me that plus 2. So I've got 3/4 minus 2 minus 3/4 plus 2. So I'm going to find my common denominator. So I put it over here. So we know that 2 changes to 8/4. So 3/4 minus 8/4, I subtract my numerator. -5, keep the same denominator, which is 4. So I got -5/4. And now I'm going to go ahead and rewrite this 3/4 plus 2 right here. So that's 3/4 plus 8/4. So 3/4 plus 8/4 is going to give me that 11/4. So I got -5/4 minus 11/4 all over 4. So combine my numerator. That's going to give me -16. Keep the same denominator. Simplify it down. My answer is -4. Okay, on number 11, the problem says to find the average value of f of x equals sine of x on the interval of pi over 4 to pi over 2. So remember your average value formula. So to find value, that's just the integral from a to b of f of x dx. And then to find its average, you just have to multiply that by 1 all over b minus a. So here's our equation. You got f of x equals the sine of x. We're going to go from pi over 4 to pi over 2. So to set this equation up, here's our b minus our a. So here's pi over 2 minus pi over 4. We're going to go from pi over 4 to pi over 2 of the sine of x dx. So now we just need to go ahead and integrate this. So the integral of the sine of x is going to be the cosine of x. And remember, since we've done integrating and it starts with a c, that's a negative. And we're going to evaluate that from pi over 2 to pi over 4. And then we go ahead and take pi over 2 minus pi over 4 here. So that's going to be, so that's 2 pi over 4. Getting that common denominator, minus pi over 4. And 2 pi over 4 minus pi over 4 is just going to be pi over 4. So let's go ahead and evaluate this, and then we'll multiply it by 1 over pi over 4. So we need to go ahead and find f of pi over 2 minus f of pi over 4. And then I went ahead and flipped this. So that's going to be 4 all over pi. So now substituting this in. So when I substitute in f of pi over 2, so that's going to be negative cosine of pi over 2. So the negative cosine of pi over 2, well, if you remember right, pi over 2 is up here on our quadrant chart. And you'll notice that point is at 0 and 1. So here's my point, pi over 2 at 0, 1. So cosine is the x value of that, so that's why that x value is 0. And then on this next one, we got the f of pi over 4. So remember pi over 4, that's going to give you the negative cosine of pi over 4. And the negative cosine of pi over 4 is going to be square root of 2 over 2. So now finishing this problem off, I take 0 minus the square root of 2 over 2. So remember that minus makes that a plus. So I've got plus right here. So that's going to give me the square root of 2 over 2. I multiply by the 4 over pi. So that's going to give me 4 square root of 2 all over 2 pi. And then the 4 all over 2 is going to cancel out. So I get 2 square root of 2 all over pi. Okay, on problem number 12, it says it wants us to go ahead and evaluate the integral from 0 to 1 of x times the square root of 1 minus x squared. So the first thing I'm going to do is I'm going to go ahead and use my algebra to change that square root sign to a half power. This kind of reminds me of what I can do. I'm going to use my u substitution. So using your u substitution, you're going to let u equal that part of the equation that has highest power, so that's going to be 1 minus x squared. Now to find out what du is, taking the derivative of my u equation, so du is going to equal that negative 2x dx. So now that I've done that, I can see that I'm missing my negative 2. So I need to go ahead and insert that into my equation. So inserting that into my equation right here, I've got my negative 2. And I need to offset that by putting the negative 1/2 out front. So now that I've done that, I notice that my u du matches up. So if I look at my equation again, I have u equals 1 minus x squared. So I'm going to take this u equals 1 minus x squared, substituting that in place of my 1 minus x squared. I get u to the 1/2. And now I notice that negative 2x dx, that is equal to du. So I substitute that in. And I still have out front my negative 1/2. So I've changed my integral using u substitution to a basic integral. Now using your rules, I can go and integrate. So remember, this is going to be the 1/2 plus 1 all over 1/2 plus 1. And 1/2 plus 1 is going to give you that 3/2. This is all over 3/2. And now I'm going to go ahead and flip it up. So when I flip it up, I get negative 1/2 times 2/3 all u to the 3/2. So now that I've done that, I'm going to go ahead and resubstitute that in. So resubstituting it in, so since u was equal to that 1 minus x squared, I'm going to go ahead and substitute that into my equation right here. I take the negative 1/2 times 2/3. That's going to give me the negative 2/6, which reduces down to negative 1/3. Now substituting in my u value, I've got negative 1/3 times 1 minus x squared evaluated at 1 and 0. So now I got to find f of 1 minus f of 0. So now substituting in this 1. So here's my f of 1 right here. So 1 squared is 1. 1 minus 1 is going to be 0. Now substituting in 0, that's going to give me a value of 1. So now I have 0 minus 1, and 0 minus 1 is going to be negative 1. And so negative 1 times negative 1/3 is going to be that positive 1/3. And that will be your answer to that integral. On the next problem, on number 13, I've got the integral of the secant squared of x, all the square root of the tangent of x. First thing I'm going to do is I'm going to rewrite it. I'm going to rewrite it so that my square root sign becomes a half power. And then since I moved it up to my numerator, that changes that to negative 1/2. So now I've got this integral of the secant squared of x, tangent of x, negative 1/2. I'm going to let u equal tangent of x, because I know from my memorization that my derivative, my tangent of x, is the secant squared of x. So you're going to notice this matches up exactly. Tangent of x is equal to my u, and then the secant squared of x dx is equal to my du. Go ahead and use u substitution to rewrite my integral. So there's my new integral. I got u to the negative 1/2 du. I'm going to go ahead and use my rules for integration to go ahead and integrate that. So remember your rules for integration. You take negative 1/2, you're going to add 1 to it, and that's all over negative 1/2 plus 1. So adding those together, I got negative 1/2 plus 1 is going to be 1/2, and then I got u to the 1/2. So I flip that bottom, and I get 2u to the 1/2. So I'm going to go ahead and scroll on up here. And I know that my u, I set that equal to the tangent of x. So since u is equal to your tangent of x, substituting that back in, you still have your 2. You got the tangent of x, the 1/2 plus c. Or you could rewrite that as 2 square root of tangent of x plus c. Yeah, number 14, it says that I'm going to take this integral from 0 to 3 of x minus 2 dx. So I just go ahead and integrate this directly. I know this is going to be the 1 plus 1 all over 1 plus 1. So that's going to give me x squared all over 2. And then remember this is x to the 0, so I have 0 plus 1 all over 0 plus 1. And that's going to give me that negative 2x. Now I just need to go ahead and find those values at f of 3 and f of 0. So substituting in my f of 3 equation, substituting this in, I got 3 to the second, which is going to be 9. I start my 2, so that's 9 halves. When I substitute into this side, I get minus 6. Now I'm going to substitute in my 0, so that's going to give me a 0 and a 0, so that's subtract 0. So now I've got 9 halves minus 6 minus 0. Getting your common denominator. Common denominator is going to be 2. So that's going to give me 9 halves. My 6 becomes 12 halves. 9 halves minus 12 halves is going to be negative 3 halves. And that will be your answer to number 14. On this last problem, on number 15, it says I've got the integral from x divided by the square root of x minus 1 dx. I'm going to want to rewrite this, moving that square root sign, changing it to its half power. And then since I'm going to move it to the numerator, that changes that to a negative 1/2. So now I'm going to find the integral of x times x minus 1 to the negative 1/2. So I'm going to let u equal x minus 1. So du is going to equal dx. So I'm going to notice that I'm missing this x right here. So I'm going to take my equation right here and I'm going to rewrite it. I'm going to add 1 to both sides, so I know that u plus 1 all equals x. Now that I know all that, I can go ahead and substitute it all in. So in place of my x, I put in my u plus 1. In place of my u value, I'm going to substitute that in. So I got u to the negative 1/2, and then I have du. So notice up here, just using that substitution. So notice I have u is equal to the x minus 1 right there. And then this one, u plus 1, goes right there. And then du equals dx. That's going to go right there. That substitutes all of my x values for u values. Now that I've done that, I'm going to go ahead and distribute my u to the negative 1/2. So I can distribute u to the negative 1/2 to this first term right here. I know that u to the negative 1/2 times u, well, that's u to the 2 halves. So I add my exponents. So there's 2 halves. 2 halves plus negative 1/2 is 1/2. When I distribute it to this last term, I get u to the negative 1/2. Following my laws, my rules for integrals, I just go ahead and take this power, I add 1 to it, and remember that's going to be all over 1/2 plus 1. So 1/2 plus 1 is 3 halves. I flip it to multiply and I get 2/3. So then I take this, negative 1/2 plus 1. That's all over negative 1/2 plus 1. I'm going to take negative 1/2 plus 1, I get the 1/2. Negative 1/2 plus 1 in the denominator is going to be just 1/2, and when you flip that 1/2, you get that 2. So my integral is 2/3 u to the 3 halves plus 2u to the 1/2 plus c. Now remember I let u equal x minus 1. So I just have to resubstitute that back into my equation. So my answer is going to be 2/3 times x minus 1 to the 3 halves plus 2 times x minus 1 to the 1/2 plus c. And that will be your integral.